Okay, ladies and gentlemen, let's go ahead with our third method of solving systems. Our third method of solving systems is substitution. Now, before we get into too much systems of equations, let's just go do something a little more basic. If I gave you this, y equals 4x plus 7, but I said x equals 3, and I want you to evaluate that equation if x equals 3. All you do is instead of having x in here, you're going to say y equals 4 something plus 7. Well, what's x equal? X equals 3, so I put in 3 right here, and I have y equals 12 plus 7. So if y equals 12 plus 7, y equals 19. That's all there is to it. We even have done more difficult things by saying distance equals rate times time. But if I'm going 55 miles per hour for 3 hours, I can find the distance by simply plugging it into the equation. So I say distance equals 55 for the rate and 3 for the time. And I come up with distance equals 165, and that's all there is to it. So substitution is something we've done previously. Usually it's called evaluate, something like that. Up here, though, now we don't have x equals 3, r equals 55. We have something a bit more complicated. Y equals 2x minus 17, and y equals x minus 10. So the thing about it is, I have a whole thing that y equals. So in this case, I'm going to take my top equation, and y I'm going to take out, and that's going to equal 2x minus 17. But what do I put in place of y? So instead of y, I'm going to put in x minus 10. It's just like a basketball game, a volleyball game, a football game. Kid goes up to the scoring desk, says, I'm going in for number 23. They wait, you buzz you in. 23 goes in, or you go in, but 23 has to come back and sit down. Otherwise, you get a foul, you get a penalty for too many people on the field, too many people on the court. So for a substitution, I take one thing out and replace it with another thing. I can't have both of them in at the same time. So in this case, I take y and I yank it out. That's gone, but I put something else in place of y. Now, in this case, the nice thing is, even though there are more pieces, instead of y's and x's, we just have x's. So if x minus 10 equals 2x minus 17, hopefully everybody knows how to solve that. Let's get all the x's to one side. And so I get negative 10 equals 1x minus 17. Let's get all the numbers to the other, plus 17, plus 17. 7 equals x. Well, very good. But now if 7 equals x, it really is like this. You can take either one of these equations, top or bottom. We're going to steal the top one. Y equals 2 times something minus 17. Well, what's the x? What's the something? I'm going to put 7 in for it. So y equals 14 minus 17. Y equals negative 3. So my solution is now 7 comma negative 3. That is my solution to this problem by doing substitution. Now over here, this one's a bit more difficult because we don't have y equals y equals. But can I pick one of these two variables and one of these two equations to get by itself? Well, I could get y here by itself, but I'm going to end up dividing by 5 and making all sorts of fractions. I could do the same thing with the x and the 3, but again, I'd make all sorts of fractions. Could I get this y in this equation by itself pretty quickly? If I subtract 3x from both sides, I now have y equals negative 3x plus 18. And now, everywhere I see y, I can plug in negative 3x plus 18. Now, here's the important part. Remember, I told you over here you could choose either equation and any equation you wanted. Here, if you use the second equation to get this, you have to use the other equation to solve. So 3x plus 5 times y, so something, equals 30. What goes in for the y? Negative 3x plus 18. Now, what do I need to do with a number outside parentheses? Give it away. 3x plus negative 15x plus, oh boy, that's going to be 90 equals 30. In this case, I come up with negative 12x, and I'm going to subtract 90, Negative 12x equals negative 60. Divide both sides by negative 12. And I come up with x equals 5. Once I know x equals 5, I can plug it back in and find y. But wait a minute, y equals all this, so just take your x and put it right there. Y equals negative 3 times 5 plus 18. So y equals negative 15 plus 18. Y equals 3. So now my solution would be 5, 3. 5, 3. Now, for those of you that doubted that, or that thought this method and this method were different, they're really not. Let's take this equation over here again. Y equals 2x minus 17. Y equals x minus 10. But instead of using y equals over here, let's get x by itself. Add 10 to both sides. And so y plus 10 equals x. So everywhere I see x, I can put y plus 10. But again, if I use the second equation, I need to bring down the opposite. So y equals 2 times something for x minus 17. The something, of course, y plus 10. So y equals, give it away, 2y plus 20 minus 17. Y equals 2y plus 3. Subtract 2y. And we come up with negative y equals 3. Well, if negative y equals 3, then that means positive y equals negative 3. Here we go. Something plus 10 equals x. So we take negative 3, plug it in, and we get 7 equals x. So my answer is 7, negative 3, which is exactly what I got earlier. So it doesn't matter which equation you start with. It doesn't even matter which variable you go to solve for. Either one of them will get you the final answer. What you have to do is keep your work organized. You'll notice it took me almost an entire page, well, a half a page, to do each of these problems. Make sure that you're using all your space wisely and organizing your work. Okay, let's do a couple problems here by substitution. Y equals 1/2 x. Y equals x plus 2. That's number 1. Number 2, y equals 2x minus 17. Y equals 3x plus 4. Now, folks, they won't always come out super pretty numbers. So even if you get a fraction, don't freak out. It just means you may make a bit of a mess. All right. For 3, we come up with 6x plus 10y equals 60, and 3x plus y equals 18. Solve that situation. So you have 3 problems to do. Make sure those are done for tomorrow.